Hello everyone, and welcome to part 2 of the quarter 3 test review. Let's get right into it. So the first topic is direct and inverse variation. So remember the general equations for direct variation. Direct variation is y equals kx, and inverse variation is y equals k over x. So this problem says that y varies inversely, so we'll be using this equation. And so we just plug in. If y is 23 when x is -2, right? Plugging in for y and x, what is the constant of variation, which is k? So all we would do is we would multiply both sides by -2, and we get k equals -46. Right. This next problem asks us, assume it varies, it varies directly. So that's y equals kx. So if y is 18 when x is 6, what is k? So this is just divide both sides by 6, and you'll get k equals 3. All right, point A is an element of direct variation. Draw 2 points other than A that are also elements of this variation. Label those points B and C. So the key is that all direct variation problems go through the origin. So that's point B. Now, it's a straight line, and so the rate of change is constant, and so this is up 2 over 3. So to find our next point, we go up 2 and over 3, and there's point C. Here on this one, once again, it is direct variation, so it goes through the origin, but now the rate of change is up 3 over 1, so we would go up 3 and over 1, and there's our other points. So there's B and there's C. These have to form a straight line. If they don't form a straight line, you did it wrong. All right, 35. Sania's paycheck earnings P varies directly with the number of hours she works H. So if she works 21 hours and earns $189, how much would she earn if she earned 32? Well, first we have to figure out what K is. So we divide both sides by 21, and you'll get K equals 9. So she's making $9 an hour. So then we plug that in. So now we know that her specific equation is pay equals 9H, because we know that K is 9. And so if she works 32 hours, that's just 9 times 32, and her pay is $288. Right, how do you determine if a graph is direct? If a graph is a direct variation graph, well, it's linear and it goes through the origin. Okay, so for this one, I'm going to have to, so in these, we're going to do them in the graphing calculator, which I need to pull up over here. And actually, I'm going to move that slightly. Here. No, don't bounce back. Don't try and do too much. No. It's going to be one of those days. All right. So here's the graphing calculator. And so what we need to do is we need to do stat. And I guess I am going to have to come over here, get it to fit. There we go. We'll just do this. So stat, edit. I already have some data in there, so I'm going to clear it out. Um, and so we're just going to plug in the data. So the x's go in L1. And the y values go in L2. Once again, we're just plugging the values in. So once we have the values in the calculator, then we go back to stat, and we go over to the calc menu. And then we go down to option number 4, and this will give us the line of best fit. Once again, we put our x's in L1, we put our y's in L2, so we can go right down here to calculate, and we get our equation. Which is y equals 40.702x plus 263.917. So that's part A. Now, so that's that. So then for part B is estimate the number of alternative fuel vehicles in 2015. But the key here is that these numbers are years after 1997. So 2015 minus 1997 will be 18 years. So x equals 18. So now we just plug in y equals 40.702 times 18 plus 263,917. And if we want to do that, we can come back over here to the calculator and just type that in. So 40.702 times 18 plus 263.917 gives me 996,553. Now up here you'll see that it shows the number in thousands. So that's actually just shy of 1 million alternative fuel vehicles. So for the next slide, it's the same thing. Now, whenever you have years, you want to rescale. So I'm going to do years since 1900. So 60, 70, 80, 90. And the reason you rescale is because otherwise you end up with a crazy number for your y-intercept, and you have to go out to tons of decimal places when you plug in your years. So once again, we're going to go into Stat, Edit, and Clear Out. And it's important that when you do this, you hit Clear, not Delete. So you hit Clear and then Enter, and that will clear out the calculator. So 60, 70, 80, 90, and there's our rescaled. And that's 5063, 6244, taking them right off the chart. 7840 and 9179. Oh, that's not right. 9179. There we go. So once again, Stat, Calc, Line of regression, calculate, and we get y equals 139.44x minus 3376.5. So to estimate this last one, this will be y equals 139.44 times 117, because it's 117 years after 1900, minus 3376.5. And if you do that math, you get an answer of 12,938. This one we don't have to rescale, so we just go stat, edit, clear, clear, and we go 3, 7, 10, 15, nope, 15, 18, the numbers are 16, 45, 82, 102, 116. So find the equation of the line of best fit. Stat, calc, line of best fit, calculate. And so once we got that, we have that. So here we have our equation. So the equation of best fit is y equals 6.711x plus 1.066. And so then you're just going to go y equals 6.711 times 125 plus 1.066. And you will get 839.941. All right. So that's it with the line of best fits. So next up, write the equation of a line that is parallel through the point -7,2, that passes through the point -7,2 and is parallel to the line. So the key thing here is that parallel. And parallel lines have the same slope. So my new line is also going to have a slope of -2. And I know that y equals mx plus b. And I know that when y is 2, when x is -7. The only thing I don't know is my b, but I can figure that out. And so 2 equals 14 plus b. Subtract 14 from both sides, and I get b equals -12. So the equation of my line parallel to this that passes through that point is y equals -2x minus 12. All right, for number 41, this is a pretty easy question, because it says, what is the line that is parallel to this equation? So the slope of that is 4/3. So that's -4/3, that's 3/4, that's -3/4. The only line with the same slope is 4/3, is A, sorry. Here, this one though is different, perpendicular. So if the slope of this line is -3, then the slope of the line perpendicular is the negative reciprocal. So you take -3, you flip it upside down, and you multiply it by -1, and then negative times a negative is a positive. But now the problem is the same as the last one. I plug in what I know. I know that y is 1 when x is 6. So my equation will be y equals 1/3 x minus 1. All right, which of the following equations is a line parallel to this one? So once again, it's parallel, so the slope will be the same. Okay, so here I need to figure out which one of these is the graph of this. So I want to solve it for y. Solve it for y so that y is by itself. Oh, sorry, that pen went a little crazy on me there. So this will be -y equals -5x minus 2. And I divide everything through by -1. And I get y equals 5x plus 2. So now I can look at my graphs and see which one is, first of all, the slope is positive. So that one's out, and that one's out. And the y-intercept is 2, but the slope is 5. And so the only one with a slope of 5 is C. Remember, just a quick thing, is lines with a slope of 1 go at a 45-degree angle. Lines with slopes greater than 1 are steeper, and lines between 1 and 0, like if it's a half or a quarter, are going to be shallow lines like that. All right. So this one is already solved for y. So I know I have a negative slope. So right away, this one and this one are out. Now I know my y-intercept is 2, and that's the same in both of them. But which one of these goes rise over run, 1 and 5? So the answer is B. All right, write an equation for a line that passes through the point negative 2, 1 and 8, 3. Now, this is kind of there's a couple different ways to attack this problem. The first one is to use the slope formula. M equals 3 minus 1 over 8 minus negative 2, which is 2 over 10, which is 1 over 5. So now I just use one of these points, it doesn't matter which one, and I plug in what I know to find B. So I would go, I'll use this point. So 3 equals 8/5 plus B. So I subtract 8/5 from both sides. And I'll get B equals 7/5. So my equation is y equals 1/5 x plus 7/5. The other way you could do this problem is, there is actually a way to do this in the calculator, is remember, if we remember what we were just doing with our lines of best fit, is that a line of best fit through 2 points is the exact line that goes through those 2 points. So you can actually plug in the points x, y, and find the line of best fit. Now, what you will see is this gives us y equals 0.2x plus 1.4. Now, your answer on the test is probably going to be in the form of a fraction. It's multiple choice, but if you do put 0.2 in and then just hit math, enter, enter, it will turn it into a fraction. And it will do the same with 1.4. So that's a nice little trick for you there. All right, let's keep rolling. So write the line that passes through the origin in 3, 5. So let's just think about that for a second. If this is the origin, 3, 5 is over here, which means that it's risen 3 and run 5, which means the slope is 3/5. If it goes to the origin, then the y-intercept is 0. And so my equation is just y equals 3/5 x. And this is a direct variation because it goes through the origin. Write the equation of a horizontal line. So a horizontal line is a line like that. And the equation of all horizontal lines is y equals some number. But all of these y values are the same, so my equation is just y equals 7. And this one is similar, but now we're talking about a vertical line. Sorry. We and it'll be in the form x equals, and all of these x points are 5, so it's x equals 5. This one, state whether the table represents a linear or quadratic function. So here is the thing, is in a linear function, the rate of change is constant. So look here, we went up 1, but here we went down 7. Here we went up 1, but here we went down, I'm sorry, that wasn't 7, that was 9. Help if I could do math. This one's 7. Here we went down 1, and here we went down 5, and then -3. So the rate of change is not constant, so this has to be a quadratic. Where in this problem, each time we're going down 1, or going up 1, sorry, the function is going down 4. So that is a constant rate of change. So this is a line. All right, and so for graphing, once again, remember, y equals mx plus b. So the slope is 2/5, which is rise over run, and I know I misspelled rise. That's intentional. And so we always start at the y-intercept, and then we're going to go up 2 and over 5. Or we can go down 2 and back 5. And always remember to double check that lines with positive slope go up and lines with negative slopes go down. This is y equals 3, so whenever we have y equals, that's a horizontal line like that. Here, this one's tricky because it is not solved for y. So I need to subtract 3x from both sides. And I'll get 3y equals -3x plus 9. And we're going to divide both sides by 3. And I'll get y equals -x plus 3. So I will start at 3. And then the slope is -1, so that's rise over 1. It's down 1 over 1. Remember, lines with negative slopes go down. And there's my graph. For this one's a little trickier. So I'm going to subtract 2x from both sides, and I'll get -3y equals -2x plus 12. Then I'll divide everything through by -3, and I'll get y equals 2/3 x, because a negative divided by a negative is a positive, minus 4. So I'd start at -4, and then I'd rise 2, run 3. Remember, slope is a pattern that repeats infinitely in a straight line. All right, and so these last two are the same thing. They're just solving for y. Instead of graphing it, we just have to mathematically figure out what the slope and y-intercept is. And so to do that, we just solve for y, and you'll get y equals 2/5 x minus 3. So the slope is 2/5, and the y-intercept is -3. So this is slope, and this is y-intercept. For this last one, it's more of the same. So this one is here. We would subtract 1/9 x from both sides. And I get -4y equals -1/9 x plus 20. Then I divide the whole thing through by -4. And I'll get y equals 1 over 36 x minus 5. So m equals 1 over 36. That's the slope. B equals -5. That's the y-intercept. If you have any questions about anything we did, please ask your teacher when you see them in class next time.